So, continuation of our partial fraction decomposition. In the previous, we already discussed the non-repeated linear factor of partial fraction. Now, this time around, we'll be treating repeated linear factors. Repeated linear factors. And what is the expression? This is the expression. How non-repeated linear factor is. Let's say this is f of x, then equals to, say, a plus x, all raised to the power, let's say 3. That is a plus x into a plus x into a plus x. That is what we call repeated linear factors. And if you look at the degree of x here is raised to the power 1. That is why it is linear. Now repeated how many times? 3. Now if you have about repeated linear factors, how we are going to tackle it is what we are going to portray in this example. Now, the first form of partial fraction, the form of partial fraction for this expression here, which is f of x, so this is f of x over a plus x raised to the power 3 will be equals to, say, a divided by a plus x. We start it one after the other, raised to the power 1 plus b into bracket a plus x raised to the power 2 plus c into bracket a plus x raised to the power 3. That is how we are going to solve this kind of partial fraction, which is a repeated linear factors. Why it is linear? The degree of the variable here is 1. And why is it repeated? Because we have raised to the power a certain number that is not 1. And that is a plus x into a plus x into a plus x. Actually, it will be more than 3 and it will be less than 3. Now, let's look at example under this. Let's look at example under this. It says resolve x squared plus 7x plus 3 divided by x squared into bracket x plus 3 into partial fraction. Resolve this into partial fractions. Say solution. Solution. Now say x squared plus 7x plus 3 divided by x squared into bracket x plus 3. Now, this is of the form of partial fraction. This is what I'm going to write it. Now, why is this repeated? Because we have x raised to the power 2 here. X raised to the power 2 here, that is x into another x. And the form of this partial fraction is going to be a over x raised to the power 1. We start with the first one, we will distribute it in plus b over x raised to the power 2. We are done with this repeated factor here. Now we are going to concentrate on x plus 3. So we have plus c, and let's take a plus c into bracket x plus 3. X plus 3. Now, say x squared plus 7x plus 3 over x squared into bracket x plus 3 equals to, and that is our LCM. It is an x squared into bracket x plus 3. There is no need for us to write this, for me to write this, but for better understanding, that is what I'm going to write it as our LCM. Now here we have A. X will eliminate one x from here, remain 1x into bracket x plus 3 plus b into bracket x squared, we remove this x squared, it will remain x plus 3. We have x plus 3 plus c, x plus 3, we cancel this x plus 3. We are left with x squared. So we have x squared. And why did I say we do not even need to write this? Why? Because the denominator of the right hand side is the same as the left hand side. Therefore, this will eliminate this. And therefore, we have x squared plus 7x plus 3 equals to, let's expand this. Ax times x, ax squared plus ax times 3, 3ax plus b times x, bx plus 3 times b, 3b plus cx squared. Now we're still using our method of comparing the two equations. And now we do that. First of all, let's arrange. Say x squared plus 7x plus 3 equals to, we have x squared, we have ax squared. I'm bringing them together. Cs squared plus cx squared. Those will be coefficient of x, those with x squared 2 are these from this what we have here. Then we have x, which is a 3ax plus bx. Then we have others too without any x, and that is what we have plus 3b. 3b. Ax, this is it. Cx squared, this is it. 3ax, this is it. Bx, this is it. 3b, this is it. All we try to do is to try to rearrange in order to be able to get what we're ready for. Now, we're not going to take the next term, so we have x squared plus 7x plus 3 equals to x squared is common to these two. Then we have a plus c into bracket x squared plus x is common to these two. Join them together, say 3a plus b into bracket x plus, we have plus 3. Is this I wanted to cancel? We have plus 3b here. 3b is 3b. So we have plus 3b. Now we're not going to compare this equation, this side of the equation to this side of the equation. Now, the coefficient of x squared here is a plus c. So a plus c equals to, the coefficient of x squared here is 1. So equals to 1. Equation 1. Now, x, the coefficient of x here is 3a plus b. So 3a plus b equals to, the coefficient of x here is 7 plus 7. So we have plus 7. Equation 2. Now, the other one which is a constant is 3b. So we have 3b equals to, what is the constant here, which is a 3. We have 3, equation 3. Now say from equation 3, which is this, 3b equals to 3. Making b the subject, we're going to have b equals to 3 divided by 3. Therefore, b equals to 1. If b equals to 1, we can substitute this value of b into this equation 2 so that we're able to get our a. Then we substitute 1 for b in equation 2. And our equation 2 is 3a plus b. Instead of writing b, I'm going to write the value of b, which is 1 here, plus 1 equals to 7. Now here we have 3a equals to 7 minus 1. Therefore we have 3a equals to 6. Making a the subject here, we're going to have a equals to 6 divided by 3. Therefore, our A equals to 2. So we got the value of B as 1 and the value of A as 2. Now we need C. We can easily substitute this value of A into this equation 1 and get the value of what? The value of C. So substitute 2 for A in equation 1. And equation 1 says A, instead of A, write 2 plus C equals to 1. Therefore, 2 equals 2. Or rather, let's make C the subject here. There's a C equals to 1 minus 2. Therefore, our C equals to minus 1. So the value of C is minus 1. The value of A is plus 2. And the value of B is plus 1. Now, what is our partial fraction now? Now we go back to this, right? X squared plus 7x plus 3 divided by x squared into bracket x plus 3 give us A. What is our A? 2. So we have 2 divided by x plus B. What is our B? Our B is 1. So we have 1 divided by x squared plus C. Our C is negative 1. And that negative is going to affect this positive here. So therefore, this is going to be minus 1 divided by into bracket x plus 3. So this is the solution of this partial fraction. You can see this single fraction is being decomposed into 3 components, which is 2 divided by x plus 1 over x squared minus 1 divided by x plus 3. If you add and subtract all this together, believe in me, we're going to have exactly what we have here. So that is example 1 under repeated linear factor of partial fraction. Now we're still going to look at another example. So we're going to look at another example here, making the second example. All right, example 2. Example 2. So example 2. Example 2. Resolve x minus 4 divided by 2x minus 5 raised to the power 2 into partial fraction. Resolve x minus 4 divided by 2x minus 5 all raised to the power 2 into partial fraction. Say solution. Alright, so x minus 4 divided by 2x minus 5 all raised to the power 2 is going to be in this kind of expression. Then we look at the form of the partial fraction. 2x minus 5 is repeated twice. That is 2x minus 5 into another 2x minus 5. And why is it linear? Because the degree here is 1. And why is it repeated? Because we have value here that is more than unity, which is that is more than 1. Then this is going to be equivalent to, say, A divided by 2x minus 5. First of all, p raised to the power 1 then plus b divided by 2x minus 5 raised to the power 2 by the second by the raised to the power 1 raised to the power 2. And we see the last one here is raised to the power 2. And that's why we have to solve raised to the power 2. Since we are still dealing with linear, we can say this is raised to the power 1. We don't have x here. When I don't have x here, this is going to be x raised to the power 0. Because one of the conditions is that the degree of the variable here must be 1 less than the degree of the denominator. So if that of the denominator is raised to 1, automatically that of the numerator should be 0. And anything raised to 0 will still give us what? 1. The 1 multiplied by 3 will give us 8. That is why we are not bothered to write anything like x raised to power 0. Now, from this point now, we can just write x minus 4 equals to, I'll not bother to write this, we should understand in our previous example that at the end, both sides, the denominator here is going to cancel the other denominator here. We have a into bracket 2x minus 5. We'll cancel one of these 2x minus 5, so we still need 1. It is a 2x minus 5 plus b. 2x minus 5 will cancel the whole 2x minus 5 here, so we have nothing here, but let's say 1. Now we have x minus 4 equals to, open this bracket, we have 2ax minus 5a plus b. Now I want to compare this equation, this side of the equation to this side of the equation here. The equation of x here is 2a. So we have 2a equals to the equation of x here is what? 1. Let's say this is equation 1. Let's write everything out first. Then we have other constant which is minus 5a. You can see there is no x here, there is no x here. So we have minus 5a plus b equals to, what is the constant here? The constant here is not 4, it is minus 4. So we have minus 4. Let's say equation 2. Now from equation 1, we can easily get the value of a from the equation 1. That is, make a the subject in equation 1. The equation 1 is 2a equals to 1. Now making a the subject here is going to give us a equals to 1 over 2. Now, we cannot substitute the value of a here. Substitute 1 over 2 for a in equation 2. And equation 2 is minus 5a, so minus 5 instead of a now. You can see this is minus 5, minus 5. Then instead of a, and our a is what? 1 over 2. We just put it in 1 over 2 plus b equals to minus 4. Here now we're going to have minus 5 multiplied by this will give us minus 5 over 2 plus b equals to minus 4. Making b the subject here, we're going to have b equals to minus 4 plus 5 over 2. b equals to, find out the LCM here. After getting the LCM, we're going to have minus 8 plus 5 divided by 2. Now what is our b? Our b equals to what? Minus 3 divided by 2. So b is minus 3 over 2. A is 1 over 2. Now going back to our partial fraction here, we say x minus 4 divided by 2x minus 5 raised to the power 2 goes to a. Instead of a, what do we have? We have 1 over 2. This is 1 over 2 divided by 2x minus 5 plus b. What is our b? Our b is minus 3 over 2. So that negative is going to affect this percent. So we have minus 3 over 2 divided by 2x minus 5 all raised to the power 2. So this is the solution to that problem. Now, this answer here, we can write it in this form. Says 1 divided by 2 into bracket 2x minus 5. And these 2 will be on the negative side. The minus the 3 divided by 2 into bracket 2x minus 5 raised to the power 2. It's still the same thing as what we had here. Or rather, we will even factorize the whole 2 outside. And that's going to give us 1 over 2 into bracket, or let's say 1 over 2, because we have a 2 here, and the denominator we have 2, and the denominator just 1 over 2 is 1 divided by 2x minus 5 minus 3 divided by 2x minus 5 raised to the power 2. All these three are the same. If you stop here, you're right. If you take it to this step, you're right. And you take it to this step, you are right. So that is the solution of this x minus 4 to x minus 5. That single fraction is being decomposed into its component. It is a as 1 over 2 and b as minus 3 over 2.